In this video, we only have this one problem, and that's to express this as a simplified single radical. So it's a product, but one is a cube root and one is a 15th root. So if they're both cube roots or both 15th roots, we could go ahead and just multiply the radicands and then simplify. But in this case, we have a 15th root. So think about it, pause the video, and see if you can solve it, and then I'll come back. Okay, let's look at this in more detail. So we have this formula for radicals. You have the nth root of x to the m. You can express it as x to the m over n. So if you have, say, the 6th root of x to the 3rd, you can write that as x. Go from a radical to an exponential and write this as x to the 3 over 6 power. And then that reduces to 1/2. So this becomes x to the 1/2, which would be the same thing as the square root of x. So let's clear this. Let's go ahead and do this then. Let's start over here and say this is going to be equal to, I'm going to leave this the way it is for right now, and then just right here 4 this would be the cube root then of x to the 5th y squared z. And I'll keep the parenthesis on this one here. This will be 7 15th root. And I'm going to rewrite the radicand here this way. So x to the 5th, y to the 10th times z to the 5th. I can write it this way. X, y squared, z, in parentheses taken to the 5th power. Because remember, power to a power, you multiply the exponent. So the exponent on the x here would be understood to be a 1. So 5 times 1 would give me x to the 5th there. 5 times 2 would give me y to the 10th there. Then z times 1, what means that 5 times 1 would give me the z to the 5th. And then I could express this radical here could be expressed as xy squared z to the 5th power, or using the formula I just went over, it would be to the 5 over 15. That would be the exponent. So the radical part would be given this way, but you can reduce this. 5 over 15 reduces to 1/3. So that would write this then as xy squared z to the 1/3 power, which would be the same thing as the cube root. So what I'll do here then, in my next step, just to save some time here, I'll just do this. And this will become a cube root. So this reduced then from a 15th root to a cube root. Now we're in business. So we have this product here is equal to, now I can multiply, have this index the same here. So 4 times 7 will be 28. And this, of course, here's a 12 in this one. Now I could multiply and simplify. So let's do it this way. X to the 5th can multiply the x to the 1st. That would give me an x to the 6th. X to the 5th times, because we have the same index here, so I can just multiply the radicand. So x to the 5th x to the first is x to the 6, but x to the 6 is a perfect cube because 3 divides into 6. So instead of having x to the 6 under the radical, it comes outside. And you get an x squared out of that. Now the y to the 12th and the y to the 2nd, I'm just going to leave it that way and say on this one, y to the 12th, y to the 12th is a perfect cube because 3 goes into 12. So 3 into 12 goes 4. So the cube root of y to the 12th, that'll come out here. I could multiply it and then y to the 12th, y squared, y to the 14th, then I have to break it down again. But here, I got it. So multiplied the 4 and the 7, got the 28. And then x to the 5th and x is x to the 6th. Break that down, perfect cube, x squared. Y to the 12th, perfect cube, 3 into 12 was 4. Now we got this z. Z is not a perfect cube, so let's go ahead and multiply and leave it under the radical. Z times z would give me a z squared. So let's do it this way then. This we already took care of, the x squared, so the x rather, and the y squared, didn't do anything with it because we simplified the y to the 12th over here. And then this z and this z multiplied to give me z squared. So we come out with the solution to this as 28 x squared, y to the 4th, that's the coefficient, and then we have the cube root, and under the radical we have y squared, z squared. Thanks for watching. We'll see you next time.